In section 5.4, we learned about having E as the base. Here in section 5.5, we're going to be doing bases other than E. And the formula is right here. Start the problem in a very similar manner. So in number 1, when you take the derivative, y prime, it's still going to be 15 to the x, just like when we had e to the x. But then we have to go times natural log of 15. And that's our answer. In a similar fashion, the answer to number 2 would be 3 to the x times the natural log of 3. All right, I think we're getting the hang of this. Let's try a few more. Number 3, find dy dx. Not surprisingly, it's going to be 8 to the x times natural log of 8. However, this problem is a little different because 8 can be rewritten. 8 is actually 2 to the third, and so really you have 2 to the third to the x, which would be 2 to the 3x, times the natural log of 2 to the third. Again, using the power law of logs from algebra 2, the 3 can come down and become a coefficient. And that is more likely to be how you see an answer written. Even though I think my answer looks a little less simplified than the step above it, technically to be simplified, you want the base, which in this case is the 2, and the argument, which is the other 2 on the natural log, to be as small as possible. Therefore, having a 2 is actually considered to be more simplified than having the 8. So a lot of times books and online sites will break it down a little further, just so you're aware of that. All right, number 4, y equals 1 to the x. It's going to be itself 1 to the x times natural log of 1. Of course, 1 to the x is just simply 1. And natural log of 1 from algebra 2 is 0. So actually, the derivative is 1 times 0, or simply 0. And quite honestly, that shouldn't come as any surprise because wasn't the original problem just simply y equals 1? I mean, sure, I threw an x on there, but that's just y equals 1. And the derivative of 1, of course, is 0. So that agrees with what we already know, which is fantastic. All right, number 5. This is a throwback to section 5.4. The derivative of e to the x is itself. But last section, I didn't tell you the whole truth. I was sheltering you a little bit. Keep in mind that e is a number. I mean, e is 2.718. That's the same thing as having just a 2 or a 3. It's just a decimal instead. It would also have to obey the rule from today. Therefore, the derivative of e to the x would be itself, e to the x, times the natural log of the base, natural log of e. The reason I didn't mention this in the last section is natural log of e came out 1 every time, so we didn't really need to discuss it quite yet. I knew I could save it for section 5.5, so I wouldn't overload you guys. Before we move to the next slide, I want to point out that my first 5 examples all had one thing in common. The exponents were all just plain, boring x. And there is a chain rule on this, just like there was last section. But the derivative of 1x was just 1, so I was multiplying by 1 and it wasn't showing it. As we move on to number 6 and beyond, we will have chain rules that are a little bit more active. Number 6, find dy dx. Okay, dy dx, or the derivative, y prime if you will, is equal to, all right, the base is a number, so it's going to be itself. So you literally copy down 7 to the 4x plus 5 power. But since the base is a number, you have to say times natural log of 7, natural log of the base, times a chain rule. What's the derivative of the exponent? And that's 4. Now, I would advise you to not leave the answer looking like that. There's a couple different reasons. Some people tend to be a little more sloppy, it's true, and this starts to look like a 7.4. The dot tends to start to become a little bit too low. Other people actually multiply the 7 times 4 and give me a 28, which is not what you mean. The 4 is not being natural logged, it's just there. So to be safer, I call this part 4 natural log of 7 when I write my answer. This way you're safe, no one's going to hassle you. All right, on to number 7. Okay, the derivative here, being that the base is a number, is going to be itself. So 9 to the secant of 6x squared power times natural log of 9 times a chain rule. We have to take the derivative of the exponent. The derivative of secant, of course, is secant tangent. Notice when I did that the argument stays the same both times. It's secant of whatever, tangent of whatever, but that whatever, that argument, doesn't change. It's whatever it used to say. And if that has a chain rule, and it does, you have to multiply by that as well. So times another 12x, I'll slip that in front. All right, I have a bit of a mess on my hands, but remember also, we want to have this completely simplified, and 9 is 3 squared. So I'm going to turn these 9s into 3 squareds. Now 3 to the second to the secant would be the same thing as 3 to the 2 secant. But the natural log of 3 squared, this 2 is going to come down and make a 2 ln 3. So I've got myself a big mess here. I'm going to write my final answer in blue. I'm going to try to squeeze it into the bottom, and I'll talk you through it. We have a 12x, but then we also have this 2 that's come down, so that's 24x. I'm going to go ahead and continue to write the rest of this. So secant 6x squared tangent 6x squared times the natural log of 3 times 3 to the 2 secant of 6x squared power. Let's just pretend that the answer actually fit on the screen. All right, fabulous. On to number 8. All right, number 8. We still have to go back and revisit chapter 2. We do it all the time. This, my friends, is a product rule. And I know that because I have x's in both parts. So we have a u, we've got a v. Let me warm my fingers up. U prime v plus u v prime. I'm going to go ahead and write the u prime and v prime off to the side, just to be safe, since things are getting a little hectic. U prime is easy. U prime is just 10. V prime is not too terrible, I suppose. It's 3 to the 4x plus 9 power, just itself, times natural log of 3, also times a chain rule of 4, so I'm going to call that 4 ln 3. All right, now I'm ready. U prime v. Just for a moment, let me explain to you what this is not. This is not 30 to the 4x plus 9 power. Again, that's bad algebra. That's actually bad order of operations, PEMDAS. You have to take the exponent before you multiply. The moment you multiply in the wrong order and you get 30, you've ruined your own really good work. So just don't do that. Don't make mistakes. Don't make mistakes. Great math advice there. Just good advice for life in general. Okay, u prime v plus u v prime, which is this stuff coming down. Okay, all the calculus is finished. That was in red. But obviously that is not a finished product as far as my answer. So I'm going to switch over to blue and I'm going to do the algebra. Similar to section 5.4, with e to the x, since it's its own derivative, well, since the 3 to the 4x plus 9 is its own derivative, it's going to show up in both parts, in both terms. Remember, the terms are right here and right here. Terms are separated by addition or subtraction signs. So you've got the 3 to the 4x plus 9 in both. You also have a 10 in both terms. So we can do some factoring, and that will simplify the answer greatly. So out comes the 10, as well as the 3 to the 4x plus 9 power. Again, let me repeat myself. This is not 30 to the 4x plus 9. Somebody's going to do it on the quiz. Just make sure it's somebody else, not you. All right, let's see what's left over. Inside the parentheses, well, the first term, I took out everything. I divided it by itself, so I have to have something left over. It would be a 1 plus. Okay, the 10 came out. The 3 to the 4x plus 9 came out. I'm left with an x and a 4 ln 3, so we'll call that 4x ln 3. You can put a dot if you like. You don't have to. And that's the final answer. All right, this will be the last example for 5.5 day number 1. Find the derivative of y equals log base 2 of the square root of 4x to the third minus 9. Eesh. All right, I'm going to take you through step by step here. So we'll start out by rewriting the original problem. In fact, we're going to do like 3 steps of algebra 2 before we really ever get into calculus. So again, remember the change of base formula. You can use that and just make it into a fraction. And as I made it into a fraction, I took the liberty of turning the square root into the 1/2 power, which is what it really is. And then, continuing on with the change of base formula, remember that you can change a pair of common logs, log, log base 10, to a pair of natural logs. Again, you can't just change one of them, but if they're stacked up as a fraction, absolutely, you've got the green light to do that. So I did. And then finally, last but not least, you can use the power law to bring that 1/2 to the front and to write it as a coefficient. All right, I'm running a little low on room, so I'm going to slide all this up a bit. And I'm going to multiply the numerator and denominator both by 2. That way, these will cancel. I don't like the fraction within a fraction look. You can see that that gives me this 1 over 2 ln 2, which again, remember, that's a number. That's a decimal. There's no x's. So I'm going to put that off to the side, off to the front, and then the rest of it will simply become times the natural log of 4x to the third minus 9. All right, we're done with the algebra 2. Now we're ready to actually take some calculus. We're going to take a derivative. Before I do that, I'm going to move the slide up one more time just to have enough room to finish out. The 1 over 2 ln 2, again, just comes straight down, being that it's a coefficient. The derivative of a natural log will be 1 over argument, 1 over stuff. So 1 over 4x to the third minus 9, times any chain rule that was in the argument, in this case times 12x squared. The only thing I see that can simplify is the 2 and the 12 can both be divided by 2, and we'll just write our final answer. And there it is. All right, that's everything. Great job on day number 1 of section 5.5. Day number 2 will be coming up shortly.